before publishing Darwin's Black Box, I was just an ordinary guy doing an ordinary job and smiling at people on the street, and they'd smile back. But when you do this, then you find out there are people who love you for it and people who hate you for it.
ID, The Future, a podcast about evolution and intelligent design.
In 2026, one of the most influential books on science in our lifetime turns 30 years old. It's Darwin's Black Box, written by biochemist and Professor Michael J. Behe. Welcome to ID the Future. I'm your host, Andrew McDiarmid. Well, today I get to conclude my conversation and invite you along for the ride with Dr. Behe as we celebrate that milestone, revisit the book's major insights, and examine its staying power over the last 3 decades. Now, in case you don't know him, Dr. Behe is Professor of Biological Sciences at Lehigh University in Pennsylvania and a Senior Fellow at Discovery Institute's Center for Science and Culture. He has authored over 40 technical papers and 3 books, Darwin's Black Box, The Edge of Evolution, and Darwin Devolves, which argue that living systems at the molecular level are best explained as being the result of a deliberate, intelligent design. Now, let's jump right back into the conversation. I'm about to ask Dr. Behe about a major intelligent design concept that he introduced to the world in his landmark book. That naturally leads us to another concept that you introduced in the book, and that is irreducible complexity. And in your words, you say it gives us a confidence that Darwin's own criterion of failure has been met. Here's how you define it in the book. A single system composed of several well-matched, interacting parts that contribute to the basic function, wherein the removal of any of those parts causes the system to effectively cease functioning. Are you still happy with that definition today? And over the years, have you come up with better definitions or analogies to help explain this crucial concept to people?
Well, yes, I am still happy with that. It gets the idea across. What I've learned in my travels, though, or some people want, if you give a definition, some people want to pick it apart. And I'm not offering a philosophical definition or some logical argument. It's just I want to describe this problem and point it out and say, hey, this is not what we'd expect for something that could be put together gradually. And in my book, in Darwin's Black Box, I offer the example of a mousetrap as a system from everyday life that encapsulates that idea of irreducible complexity. And it gets the idea over very, very well. Just take a piece away and the mousetrap simply doesn't work. And many molecular machines are exactly like that. And it shows the problem for Darwin's theory very well. And again, in the 30 years since the book's been out, nobody's been able to say how that problem could be circumvented. And experiments that test evolution in the lab also show no indication that random changes in natural selection could produce some coherent molecular machine, such as those that fill the cell. So yeah, I'm very happy with it. Some people have poked it and prodded it. But again, I'm not trying to offer a philosophical argument. I'm trying to offer a scientific one to point out a problem, and that has stood up pretty well.
Yeah. And as you say, for years, your critics tried to refute the theory of irreducible complexity by claiming that the type 3 secretory system, for example, found in some bacteria, was a precursor to the flagellar motor that you made famous as an example in your book. But it turns out we have good independent reasons why that system is not ancestral to the flagellum. Can you speak to that just briefly?
Sure. For anybody who doesn't know, after I wrote about the bacterial flagellum, a couple of years later, it was discovered that it was more complex than had been known in my when I wrote the book. And in that, not only was it a rotary motor, but it could also actively pump proteins through a hollow tube in itself to help construct itself. It has unlike machines in our everyday world, the bacterial flagellum has to build itself, or the cell has to build it gradually. And that was part of the mechanism to help build it. And
Hmm.
so some people, as you mentioned, said, well, look, we have now discovered another molecular machine that has a number of components of the flagellum, but it acts simply to pump proteins. And it's also got a little needle-like complex that pumps toxic proteins into a cell that a bacterial cell is trying to catch and kill and eat, called the injectosome, or the type 3 secretory system. They said, well, maybe that was a precursor to the flagellum, and then we could add on this extra rotary motor stuff. And there's a couple things to say. First is what you alluded to, is that later work showed that, in fact, the bacterial flagellum is older than the smaller, less sophisticated type 3 secretory system. So the type 3, the simpler thing, couldn't have been the precursor of the more complex thing. If anything, the more complex apparatus would have degraded or devolved, maybe, to give rise to the simpler one. But that's no Darwinian explanation to say you've got this super complex device, which, if you break it, you can save some of the function of it by using it as a different molecular machine. So that didn't pan out the way that the critics wanted it to. But another thing that many people overlook is that pumping proteins through a tube, like the type 3 secretory system does, has nothing to do with making a rotary motor. It is logically and mechanically separate. So it doesn't, even starting from that, you still haven't gone anywhere towards explaining how this rotary motor came about. So, and a third thing is that for all of these hand-wavy stuff, like, well, maybe this acted as a base and these other portions, you're still talking at the level of, well, maybe our computer had a keyboard and then we added this wire over here. But for each of these higher level things, there are many, many very difficult mutations that would have been needed, even in the best case scenario, which would themselves have made it virtually impossible to have done by Darwinian processes.
Yeah. And it's easy to gesticulate about, adding this and adding that, but we have to remember that a Darwinian process is blind and cannot go looking for things. It can only take on what it stumbles on, right?
Exactly. And it turns out, maybe we'll get to this later, but in later work, really great laboratory experimental evolution systems have done exactly that. They have been let to evolve, and they do not form more and more complex structures. What they do is break different genes, and sometimes breaking genes help, and they throw away this and they throw away that. And by throwing stuff away, it helps for the moment. But it turns out that from our best laboratory work, it seems that Darwinian evolution does work, but the way it works is by using genetic information as fodder to throw away in order to produce short-term benefits for an organism.
Yeah. Yeah. And we will definitely touch on that in just a moment. As I mentioned, kind of the books that you worked on afterwards. Now, since 1996, we've obviously learned an enormous amount about the cell. Has the new knowledge strengthened or weakened the central case of Darwin's black box?
It only strengthens it. I mean, just as a general principle, if you've got something mysterious and you discover new substances, that doesn't explain the mysterious machinery you've got. So all of those things that I talked about, they're not going away, no matter what else is discovered in the cell. And the cell itself has only gotten more and more and more complex the more that is known from research. I discussed one or two molecular machines, the psyllium, the flagellum, that are involved in mobility. There's, another, 5 or 6 that have been discovered since then that act on different principles. I talked about gene regulation in I don't think it was Darwin's black box, but other ones, and the complexity of gene regulation, what turns something on and off, and it turns it on if some other condition is true or this condition is false, and the genetic regulation has turned out to be astoundingly complex. So no, the cell has only gotten much more mysterious, much more sophisticated than we knew back in the day.
Yeah. And so, I want to point this out that when you do become revolutionary in your thinking and a dissident, and going against the grain, that can have an impact not just on your career, but also on your life. So I was wondering how Darwin's black box and the impact of the book affected your career and also your life at the time.
Well, let's see. It affected my career in a couple ways. First, I devoted more and more time to that, and I became more and more radioactive within academia, because academia as a whole is antagonistic to things with theistic implications, and especially in biology. In my personal life, sometimes things, were not very pleasant, but I have to say that I myself was shielded from a lot of the abuse that other folks in the ID movement had to endure. I had tenure, as I said at the time, so my job was secure. Other folks actually lost jobs or were kicked out of labs and so on.
Yeah.
And I have to tip my hat to my colleagues at Lehigh, although they put up on their website a disclaimer saying that there is only one crazy guy in our department. Don't blame us, please. They also said that we respect Dr. Behe's right to think as he does and to write as he does. So they were always supportive of academic freedom. That was not the case for many other places. Nonetheless, it's before publishing Darwin's Black Box, I was just an ordinary guy doing an ordinary job and smiling at people on the street, and they'd smile back. But when you do this, then you find out there are people who love you for it and people who hate you for it. You cause all these different reactions in people, and that was disconcerting. But that's the way the world works. So
yeah. Was it Paul Nelson at the event that reminded us that if one way you can tell if you're making a difference is if people get upset or have a strong reaction to the things you're doing, right? It shows you're getting somewhere.
That's right. You can talk about things nobody cares about, and they'll smile at you for a long time. But if you go to a foundational or a core idea in society, there are folks who have a lot invested, one side or the other, and rightly, these are important ideas. But when you start talking about them publicly, people can react to it.
Yeah. So Darwin's black box had a major role in propelling the argument for intelligent design forward and forcing scientists to grapple with the biochemical challenge to evolution. What impact do you think it has made beyond science in, say, philosophy or education or just the broader culture?
Well, it's difficult to say for sure. There aren't, great metrics or something, but in my sense, in my travels and talking to people, it's made people more aware that claims for evolution are oftentimes inflated. And as the internet and social media and stuff become more and more prominent in communications, it's made it more easy for people to believe that the gatekeepers were not being completely honest with them or straightforward with them. So I think that everybody these days, when they're talking about origins, has to take into account the ID point of view. Nobody is anymore, at least anybody who's thinking seriously will default say that Darwinism must be true because we have to explain it, because that's the way we're required to explain it. Some people might say that, but they're not being intellectually serious. They might be trying to propagandize other folks. But serious thinkers in science, philosophy, theology, education do now grapple with an idea they were not grappling with before.
Yeah. Well, you wrote 2 books after Darwin's Black Box, The Edge of Evolution and Darwin Devolves. Do they expand the same central thesis of Darwin's Black Box, or do they cover, in your opinion, whole new arguments and directions?
Well, yes and no. In Darwin's Black Box, that was the case for intelligent design. First of all, I showed why the machinery of the cell, number one, it wasn't explained by Darwinism. And number two, here are some problems that Darwinian processes would face in trying to produce such things like irreducible complexity. And then I also made the positive case for intelligent design, that we perceive design in the purposeful arrangement of parts. And so that is the positive case for design. And everything in the cell that I pointed to before still is very purposeful, very clearly has a function, and points strongly to design. In the next 2 books, Edge of Evolution and Darwin Devolves, I wanted to concentrate more on the question of, well, given that there is design in the cell, but, randomness is there, chance things happen, how much could a Darwinian process explain? If you're like me and you think design extends into life, this far, but maybe chance can explain things at the surface level. Well, how deeply into life does design go, or how much can randomness explain? And so the second book, The Edge of Evolution, was just that. I wanted to get where is the edge that Darwinian evolution can explain. It can explain up about this far, but then you need design to account for the other complexity in the cell. And I used then newly reported results about the ability of malaria, the malarial parasite Plasmodium falciparum, to develop resistance to the antibiotic chloroquine, and showed that, well, if you just need one mutation, Darwinian evolution can account for that. But if you need 2 mutations to achieve some selectable result, then you have hit the edge of evolution, that it's very difficult, although not impossible, for an organism, especially one with the large numbers that malaria has, to get that. It turns out, I'll just give an example for listeners, that there's an antibiotic called atovaquone that was used to treat malaria patients. But when you treat them, you have a clinic with a bunch of sick people coming in. You treat the first person, she gets better. You treat the next guy, he gets better. You treat the third one, they start to get better, but then they get sick again. And it turns out that one of the cells in the third patient spontaneously got a mutation that conferred antibiotic resistance to atovaquone. So every third person could develop that antibiotic resistance. With chloroquine, you could do 1, 2, 3, 4, 5, 6, 7, 8. It took 1 billion people you had before the malaria produced a resistant cell. So something like 100 million times the number of trials to produce resistance to chloroquine than to the first one. Without getting into the gory details, I made the case that this shows us the definite edge of evolution, that we can extrapolate this to generic equipment in the cell, the difficulty it would be to get two proteins to bind together, and that evolution might explain things up through the level of order or so, the biological level of order, but not higher.
Yeah.
In my subsequent book, Darwin Devolves, I showed that in fact Darwinian processes actively degrade a lot of genes, and I argued that, I was too generous in the last book, that Darwinian processes can't produce anything beyond the family level of biological classification. And that, just as a marker, is like the difference between dogs and cats. So you might get dogs, you might get wolves, you might get kitty cats and lions and leopards and so on, but evolution can't produce the difference between a dog and a cat. So design extends at least down to the level of family. So those things pushed the boundary. It showed how far design extends, but it did so pretty much by showing the limits of Darwinian evolution.
Okay. And then Darwin Devolves, of course, revealed, that the change comes about by the breakdown of genes and genomic material rather than building it up and innovating it. So all three books, can they be read together, read separately? Is it a trilogy? Is it fair to say?
Yeah, it's just like Lord of the Rings. You have to start. You have to start in
by appreciating the design
back
element.
end. Yeah, yeah. It's best to read them sequentially because again, Darwin's black box emphasizes design and shows the basic point that science, despite much bluster, has not explained where these things came from. I think you could probably skip ahead after Darwin's black box to Darwin Devolves, which is my most recent book that was published in 2019. And that'll give you an update on everything. And it makes the important point that you mentioned, that in fact Darwinian processes do work, but they work mostly by breaking genes that were already there, and that oftentimes can give a helpful effect, like breaking a gene that colors the fur of a brown bear so that its fur is white, and that gives it an advantage in the Arctic against the ice and snow. And that's interesting, and it helps that organism survive, but it does so by breaking a gene. And there are many more examples in the book like that.
Yeah. Yeah, I was blown away when I came across that idea, because it just turns Darwinism on its head completely. And of course, we have podcast episodes that we've done with Darwin Devolves, I think a multiple part series. So listeners, viewers can go back and find that. Well, Mike, is biochemistry uncovering more black boxes still today? What are the biggest unanswered questions in your field that linger?
Yes, it's great. The new techniques are being invented which allow scientists to probe deeper and deeper and deeper, even into molecular machines like the bacterial flagellum and ATP synthase and the ribosome. It turns out that even with microscopes, you can't see everything, or even with electron microscopes, and there are new techniques. And the intricacies of these machines are beyond anything, even I imagined back in the day. But I think probably the most exciting and area is, again, I mentioned before, this area of regulation. What turns a gene on and off. Different genes have to occur at different times of life. You go through puberty, and different genes are turned off and other ones are turned on. They wouldn't do to have everything going on all at once. And a baby is developing in the womb, different genes get turned on, sometimes just for minutes at a time, and then turned off. What tells them, what controls when they turn on and when they turn off? It turns out that it's much, much more intricate than we knew, and that there are more classes of molecules, RNA molecules, that are involved. And so, for each year that passes, the complexity only increases. And as I reemphasize, even the stuff that was pointed out in 1996, nobody has been able to explain. So this is just piling the unexplained on top of previously unexplained.
Yeah. And this is not an official question. I know it's not in your wheelhouse necessarily, but have you pondered how the quantum realm interacts with, the biochemical challenge to evolution, and how everything is at the molecular level and beyond? Is the quantum realm sort of another black box that you can include in all of this?
Yeah. Well, the short answer is no, I haven't pondered that, but other people have, and I've kind of, skimmed what they had to say. But, at best, the quantum realm might be an area where a designer could manipulate things to get stuff done without, being too obvious about it. And some people are theologically invested in the designer covering up his tracks, but it doesn't matter for our conclusion.
Yeah.
When we decide something is designed based on how it looks right in front of us, not how it got to be the way it is. We see the flagellum and it's an outboard motor, and we know outboard motors are designed. If you see the faces on Mount Rushmore, it doesn't matter if they were carved with pickaxes or somebody had a powerful laser that he used to carve out the faces. Doesn't matter if they were made by humans or space aliens or the finger of God. It doesn't matter, because you can tell just by looking at these faces that they were designed. So the conclusion of design is robust against what we discover next or what other forces in nature are acting.
Yeah. Well, Mike, you've given us so much, with the books and your scientific work and research. I just wondered, is there something we can look forward to that's coming down the pipeline for you? What are you working on now?
Well, I'm actually got a kids book, or a book for teens coming out. It's kind of an adaptation of some videos that a man named Cal Covert, who's a videographer, put together of me, called The Secrets of the Cell, where I go and explain different systems in the cell. And some folks at Discovery thought it'd be good to have this explained clearly for young folks who are capable of grasping it and want to, see why we can be confident that life was designed.
Yeah.
Other than that, I'm just I don't have a brand new book in the pipeline, but I am busy writing different essays and articles defending the ideas and arguments that I've made already.
Okay. Well, yeah, the children's book sounds awesome. As a homeschool educator myself with my wife and our three daughters, I know that they kind of come alive when they watch the molecular machine videos, and it sort of confirms that intuition that Doug Axe reminds us is built into us. And they just kind of light up when they tap into this molecular level of life. So I'm looking forward to seeing the young person's book that you're working on.
Great. Yeah. It should be fun. Yeah. It's always fun when you can see something that encapsulates an idea. And when you see a kinesin motor walking along, pulling some cargo behind it, or a flagellum spinning, the lights go on.
Yeah. Well, Mike, I'm grateful to you to have joined me today. I know you just came back from a visit to the Seattle area, so thank you for helping us to celebrate this milestone of your book and the achievement.
Oh, thanks for giving me the opportunity to speak to everybody today.
Yeah. Well, audience, if you haven't read Darwin's Black Box, now is the time. You'll see it on my shelf back here. I have one of the original 1996 hardcover copies. But however you can get your hands on it, whatever edition, it's a great book to start with if you want to dive into the biochemical challenge to Darwinian evolution. The book is written to be accessible to the lay reader. You don't have to be a scientist or with a PhD to understand it. It has doses of technicality in the example chapters in the middle of the book, but the opening section, the closing section, all written in everyday prose that can easily be grasped. So you can get a copy of Darwin's Black Box at Dr. Behe's website, as well as his other two books. That's michaelbehe.org, michaelbehe.org. And on this last note, you mentioned videos. The Secrets of the Cell series is available at michaelbehe.org, as well as just on YouTube. And that's definitely a series you're going to want to share with your friends, kids, associates at work. And there's one other video that I thought of just as we were talking today, and that is a film that we put together called Revolutionary. And it tells the story of Dr. Behe and his books and the arguments that he's been unpacking over a quarter century and more. And if you want a visual look at all this and to see in vivid detail what Dr. Behe has accomplished, I recommend you look that documentary up. There's a website actually still working and still able to point you in the direction of the video. It's revolutionarybehe.com, revolutionarybehe.com. So that's another video resource that will enlighten you to Dr. Behe's work. Well, it's all at michaelbehe.org. And Mike, appreciate your time. Thank you very much. For ID the Future, I'm Andrew McDiarmid. Join us again next time for more.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.